And this time, welcome everybody, we are featuring the Model My Watershed water quality tool. So thank you all for being here today. I'm Michelle Perez, Water Initiative Director for American Farmland Trust, and I'm joined by two colleagues, Aysha Tapp-Ross, and she's our Water and Soil Health Scientist, and Kinzie Reiss, our Ag Conservation Innovations Program and Communications Manager. Brief, that's a long title, love it. And for those of you who don't know, American Farmland Trust is a national nonprofit founded in 1980, and our mission is to save the land that sustains us by protecting farmland, promoting sound farming practices, and keeping farmers on the land. And so for today's webinar, after a few reminders, some recap, and a quick poll to see who's in the room, we're going to hear from Model My Watershed tool developers Anthony Aufdenkampe of Limnotech and Matt Ehrhart of the Stroud Center. And they will lead us first in a presentation and then a demonstration of the Model My Watershed tool. And we've reserved the last 15 minutes of the webinar for Q&A. And we want to thank our funders, the EPA Office of Water and the Walton Family Foundation for making this webinar series possible. And I'll turn you over to Kinzie now for some housekeeping reminders.
Thanks, Michelle. Hi, everyone. This is Kinzie Reiss. We are using the Zoom webinar platform for this series. So that means as attendees, you'll have your camera and microphones turned off throughout the event. You can use the Q&A feature at the bottom of the screen at any time to ask questions, and speakers will answer the questions during the last 15 minutes of this event. You can use your name or be anonymous when asking questions or making comments. You can also vote up questions you want to be prioritized. And if you'd like to verbally engage in a conversation with the speakers or us, we just ask to be unmuted and we will do so. If you're having any technical difficulties, you can direct message me in the chat box and I will help you out. Following each webinar, you will receive an email within 3 to 4 days that will provide the recording and the slides for the presentation, as well as information about the next month's speaker. And by the following Monday, we will post the recordings to the webinar registration page, which we absolutely welcome you to share with colleagues and friends that may be interested in viewing. To help us improve our webinar series, Michelle is sharing in the chat box a link to a 6-question anonymous evaluation survey that should take about 2 minutes to complete. Please click on that now so it opens a new tab on your browser, and please complete that survey right after the event ends.
Thanks, Kinzie. And it looks like I don't have the privilege of sharing with everybody. So I shared with who I could, which was you. There. So maybe
I'll drop that in there.
Thank you.
Everyone. There we go.
Great. Thanks.
All right. Okay, let's see who's in this room for this event. We have 3 quick poll questions that you will see come across your screen as soon as I launch them. Right here. There we go. Question number 1 is, which one sector best reflects your occupation? Government agency, non-government organization, academic institution, corporation or environmental markets firm, or other. Number 2, if there are only 4 types of audience members, which one best describes you? Developer of outcomes estimation tools, methods, or models, current user of outcomes estimation tools, methods, or models, potential future user of outcomes estimation tools, methods, or models, person interested in learning about outcomes estimation tools and issues. And number 3, what is your experience level with the Model My Watershed tool? Had not heard of it, but never used it, heard of it and used it, or I refer to it often. So a couple seconds. About 80% of people, we're getting higher. I've filled this out, so. Just maybe get a couple more in there. All right, gonna go ahead and end the poll and share the results. So it looks like most people are from the government agency or non-government organization. the majority are a potential future user of outcome estimation tools. And as far as Model My Watershed, a lot of people have heard of it, but never used it. So that is a great segue into what Matt and Anthony have for us too. So I'll turn it back over to Michelle.
Great, thank you, Kinzie. So before we continue any further, we just want to do a brief recap of the launch event from May 3rd. So during that first of our series event, AFD staff gave an overview of the needs assessment results and how we used preferences of the folks who completed that 20-minute needs assessment to organize and prioritize the series. We presented several sections of the Outcomes Estimation Tools Guide, and we had the world debut of the Project by County Outcomes Calculator tool, or better known as the Peacock tool, which is a very simple coarse water quality and GHG outcomes calculator that AFT developed for outcomes estimation in Illinois for solely cover crops and no-till. And Kinzie's providing that link to that Peacock tool in the chat box now, thank you. And if you want to access any of those resources and all upcoming resources, you're going to find them very soon on a new site we've created at the American Farmland Trust NRCS Farmland Information Center, or FIC website. And that's going to house the recordings, the presentations, additional resources provided during each webinar. And Kinzie will put the link to that chat as well. Go ahead and bookmark that so that you can refer to it as the content will build as each webinar proceeds. So thanks for that. All right, and so the new FIC site and this webinar registration site, you might be familiar with this. This will list all of the webinars in the series, and Kinzie is going to share that link again. So one thing to notice is we have one date change announcement to make. We moved the July webinar from the first Wednesday of the month, July 5, to the second Wednesday of the month, July 12, to avoid the July holiday week. And because we want everyone's calendars to be updated, we're going to take a moment now, just 30 seconds, for you to manually change, make that change in your calendar, or do something else if you've already done this. So navigate to your calendar, open the July 5 calendar appointment to just that one in the webinar series, manually change the date to July 12, or you can re-download the entire series following the link in today's email. So we're going to have some fun musical accompaniment while we give you 30 seconds to do that. And maybe, so you're hopefully all imagining the Jeopardy, the Jeopardy tune going on right now for that. All right, we're just going to have to imagine it. That was our fun musical accompaniment. So I think we're almost ready, if that was enough time for people to do that, or remember to do that. And we're going to turn it over to Aysha now for next steps before we hand it over to our tool developer guests.
Sorry, should have practiced that piece before we actually did it. Okay. All right, great. Thank you. So I'm Aysha Tapp-Ross. And here are some of the next steps in our collective outcomes estimation journey. So first, we look forward to you joining us at some or all of the next set of tools training webinars that will be held the first Wednesday of every month, except for the July and January events, which will be held on the second Wednesday due to the neighboring holidays. And if you can't make it to one or more of the webinars, but want to view the session, the recordings should be available by the following Monday. Second, at the end of the webinar, there will be an opportunity to share your feedback with us by answering a quick 6-question survey. Kinzie shared the link in the chat box at the beginning of the session, and it will also appear as a new tab in your internet browser when the webinar ends. Please take a couple minutes to share your feedback so we can keep improving these events. Michelle and I are also offering free coaching services to the now 7 farm project managers who secure a session with us. These sessions are individually tailored to you in order to help you figure out which tools or methods are right for your project. If you're interested, just email me, Aysha Tapp-Ross, and in the subject line, write coaching. Coaching request, sorry. And finally, if you'd like a free print copy of the guide to be mailed to you, you can place that order online at the report's website, which you can easily find using the keywords AFT Outcomes Tools. And now, I guess, are we handing the webinar over to the Model My Watershed?
Great, thank you. Right. Anthony, go ahead and share your screen or give the screen privileges, Aysha, or
Yep.
maybe it's. And we'll have Anthony and Matt take the time to introduce themselves as well.
Thank you. Should all be seeing my screen.
There's what appears to be some coding in front of, yeah. Did you want to show your a coding screen or a file system screen rather than your
spreadsheet tool, Anthony?
Oh. Clicked on the wrong button. Seeing the presentation?
Yes, great.
All right. Thank you all. First of all, Michelle, Aysha, Kinzie for inviting us to present. I'm Anthony Aufdenkampe. And Matt Ehrhart and I will be presenting today. I'll be leading with some slides. The lead for the Model My Watershed, Dave Arscott, sends his regrets. He is unavailable right now on an airplane. So he won't be able to join us, but he helped prepare the presentation and isn't here in spirit and has been working with the American Farmland Trust team from the beginning on this project. So thank you all in the audience also for your interest in Model My Watershed. It's really an honor to have this many people interested in this tool that we've been working on since 2010. And we're really excited to present to you the state of Model My Watershed and how it's being used. So I'm going to give some introductory slides and then in the middle, Matt will do a live demo of some of the kind of workflows that are being used. And he has some examples queued up from the Midwest. And then it will go back to me to talk about the future, where we're headed, and kind of wrap up some of the conversation about this before we finish in about an hour or less, to leave about 15 minutes for Q&A. So now it's time maybe for Matt and I to introduce ourselves. So as you can see on the screen, I'm a senior environmental scientist at Limnotech, but it wasn't always so. I joined Limnotech in 2016 after 14 years as a senior scientist at the Stroud Water Research Center, where I led a group looking at integrative whole watershed water, carbon, and mineral cycles, looking at how essentially humans impact water infiltration, erosion, deposition, and how those things combine to affect net carbon balance on kind of a whole watershed perspectives from soils to sea. And I got there with a background, I have a BA in chemistry with a minor in ecology from Dartmouth College, and then went on to a master's in chemical oceanography at the University of Washington, and then converted to from an oceanographic perspective to a river freshwater perspective with a PhD also in the chemical oceanography program, but studying the Amazon River and its role in the global carbon cycle, which led to a number of important publications and had me working not only in the lowland Amazon that you're all imagining, but also quite a bit in the Andes, because we were looking at the whole Amazon watershed and how it transported minerals and carbon from the Andes, along with lots of rainforest carbon into the oceans and also back to the atmosphere. So that background was important in this modeling. Oceanographers are very quantitative. We're very integrative. We're looking at how to synthesize knowledge with data systems and computational systems. And so that led to me co-founding the Model My Watershed project while at the Stroud Water Research Center, conceptually back in 2006, but with real true funding in 2009. So with that, I will pass things over to Matt for a brief introduction of himself and his role and his roles and background, and then we'll move on into the slides.
Okay, thanks, Anthony. Hi, everyone. I'm Matt Ehrhart. I'm the Director of Watershed Restoration at Stroud Water Research Center. So the watershed restoration team is about 7 people at Stroud currently. We are focused on design, implementation of restoration activities, probably 85% agricultural in nature. To give you a brief idea of scope, we probably work with 34 to 36 farms a year on sort of comprehensive conservation planning and implementation. In addition to those farms, we probably work with probably 6,000 or 8,000 acres a year of farmland on soil health implementation work, and another maybe 130 to 150 acres of riparian forest buffer establishment. Sort of the bulk of my team's work, in addition to serving as technical advisors for other folks. Prior to coming into Stroud and building the watershed restoration program about 11 years ago, I worked at the Chesapeake Bay Foundation as director of their Pennsylvania office. My master's degree in engineering from Penn State, and I think, to be fair, I'm probably better classified as a user of Model My Watershed than a developer. But I think our teams made extensive use of the tool in conjunction with the science team at Stroud and other colleagues from other places like Anthony, looking at sort of the aggregated implementation of conservation work and measuring and monitoring those outcomes, as well as lining that up with using the model both in a planning context and sort of as a tracking and outcomes tool. So I will pass it back to Anthony to kick us off.
All right. Thanks, Matt. Designing a tool like Model My Watershed really requires a whole team of people, as Matt was just describing, people who understand the workflows of conservation practitioners and exactly what they need to make the kinds of science-informed decisions that they want, funders, water scientists, modeling experts, et cetera, including software developers, educators. And so this is really a time to make a shout out to all the different people who have contributed. You can see that Model My Watershed has been really a multi-organization collaborative effort really from the very beginning. So a lot of people here to thank. You can also see that Model My Watershed, that we mentioned, this umbrella project called Wiki Watershed, and that is from the very beginning, back in 2006, when Susan Gill and I, the second director of education at the Stroud Water Research Center, the two of us kind of brainstormed this idea of like, how can we like merge these new emerging things like Facebook, Wikipedia, and Google Earth into something that would be useful for watershed decision makers and stakeholders. We came up with this concept of Wiki Watershed, and presently Wiki Watershed has been implemented to kind of include a family of programs for which Model My Watershed is the flagship. It was always the biggest part of the vision, and it was the first that was funded, but now you can see there's lots of other components to this work, including a companion Monitor My Watershed that we'll mention very briefly. So let me tell a little bit of the history before we dive into a little bit more about it. So Model My Watershed, Monitor My Watershed, Enviro DIY, which is an open source environmental IoT sensor station system, and which are all part of Wiki Watershed, plus some additional efforts that are kind of connected to this. We started with an idea, at least from the Model My Watershed part, like I said, from 2006, that was funded by the National Science Foundation as a pilot to how could we do some real world watershed modeling in a way that was simple enough for middle schoolers and high schoolers to understand it. And it turned out it was very successful. The evaluation at the end of that first phase of work was so compelling. The evaluator said, wow, we've never seen a tool that could be used equally well in a middle school classroom, a high school classroom, and even a college classroom. We're noticing that tons of college courses, introduction to hydrology or watershed science or water quality, are using this tool. And I know now that it's even being used in graduate level school classes. It's actually part of a week-long course taught in the Harvard School of Landscape Design. So anyways, that investment, like I said earlier, was initially pitched to educators and students, but it was so successful that we started recognizing that, if you put together these ingredients, real water data with real landscape analytics, real hydrological models, the same models that are being used by professionals for decision support, for watershed conservation, approved by state agencies, et cetera, and then allow you to run different scenarios and compare the results of different management practices, that essentially that results in what is really a decision support system. And we convinced the William Penn Foundation that it was worth investing further in such a system, not for educators and students, but rather for conservation practitioners, land use decision makers. And that's because the William Penn Foundation had launched the Delaware River Watershed Initiative, in which they had funneled at the time more than $60 million in watershed conservation activities. And so they felt like what eventually amounted to a $5 million investment. It was in little chunks, not so little, really, like $1 million chunks at a time. Was a wise investment. I think $5 million is about what they've currently invested, and I think their current investments in the watershed conservation are upward of 100 million now, right? So 5% of their investment in conservation, they put in a tool that could serve these decision makers. And their thinking was that these tools could be used for effective planning around conservation planning, that it could also be used for effective conservation implementation. And then finally, by doing these things well, you end up with effective outcomes. William Penn Foundation has always been very outcome driven, and that was their goal. So this is kind of this return on investment. This is why they invested in Model My Watershed. So it's a pretty significant amount of investment. And I will say that, not all of that investment went in just developing the tool, but also programs around the tool, especially education programs. But at least half of that was spent on software engineering, because Model My Watershed really is very special under the hood, and we'll talk a little bit more about that later. So what is it? Well, we're presuming that you all have a bit of an idea of what it is, but in brief, and we're going to go into the weeds in a moment so that you can learn a lot more than hopefully you came to this webinar with. But in brief, it's a web application. So it's not just a web page, but it's a full-on web application. It's like software, but that software that runs in the cloud, that is designed really, even when back in the day of our education efforts, designed to be a conservation decision support. It's designed to give conservation practitioners the information that they need to make decisions about how to implement conservation practices in their watersheds. It does some pretty cool things under the hood. You can click on any point in the map to automatically delineate the watershed and then run a watershed model. It fetches that modeling information, and here's a little screenshot you're going to see more later, and then it quantifies those benefits and allows you to apply different scenarios. It's widely used. We have about 15,000 registered users. About 10-15% of those are active users using things. There are 40,000 uses per month where people actually initiate a watershed model. They're not just page views, but people actually initiate a watershed analysis or modeling effort, and that's not something you just land on. You actually have to choose a point on a map or an area on a map. It's won 4 awards. Most recently, the Amazon Web Services, AWS Innovation Award, I think in 2019. And it is presently a preferred tool by the state of Pennsylvania for both total maximum daily load modeling and also MS4 stormwater permitting. Department of Environmental Protection, DEP, Pennsylvania DEP is beginning to invest in that. As I mentioned earlier, it has some high performance features that allows us to run these like 30-year daily water balance models over large watersheds. It can automatically delineate that watershed, which takes some high performance computing capabilities, and run that model. And also it's under the hood. Under the hood, all the code is fully open source and it's designed to be expandable. So we'll get into that later, because what you see now is just the potential of what could happen. And I guess I'll say up front, we're actively looking for the next round of funding to develop even more features. We have quite a bit of features that have already been developed, but there's so much more that could be done with this platform. So if you like what you see and you have ability to influence decision makers about funding for this kind of work, and don't want to see this amazing investment go to waste, you know, we can talk, because from the ground up, it's designed to be modular and expandable in terms of its geography, and we can talk more about that later. So here's a few more details to tell you more about what it is. So right now it operates anywhere in the conterminous or continental United States, what's called CONUS. It uses the National Land Cover Data Sets from USGS, the 2019 product that actually includes apples to apples land cover assessments from 2001 all the way to 2019 in 3 to 6 year increments. It includes soils data from USDA. We're going to get into the details later. Elevation data from USGS and EPA, information about protected lands, agricultural animals, point source information from EPA, et cetera. There are actually 2 different models that operate in the system right now. A stormwater model that models a single stormwater event, like over a hypothetical 24 hours. It actually uses a kind of a hybrid of TR55 and WindSlam, which was an optimized version for urban areas. WindSlam is a commercial product that is still being used right now in urban areas by civil engineers to design stormwater features. And it has a water quality component that takes the algorithms out of EPA's STEP-L software. It's a STEP-L is basically a spreadsheet tool. That's one model. The model that we're going to spend most of our time on, and that Matt's going to demonstrate, is the watershed, what we call the watershed multi-year model, and that's built off of what is most recently been called MapShed, which was an open source desktop application funded by Pennsylvania DEP for more than a decade. And that itself was built on the Generalized Watershed Loading Function Model Enhanced Version, GWLFE, which was approved by EPA for TMDL and MS4 permitting, which is why Pennsylvania has used it. So GWLFE is actually widely known across the country, but because Pennsylvania adopted it for its ease of use, for the fact that it was open source, it's most widely used in the Mid-Atlantic, but it is approved all over the country by EPA at least. So what we're about to show you is actually the evolution of these things. Pennsylvania DEP is now said, instead of using Mapshad desktop tool, use Model My Watershed because it's more capable, more up to date, uses better data and better algorithms. Please use Model My Watershed. So that's happening right now. We'll talk a little bit about that. And then there's the ability, as I mentioned earlier, to run different scenarios of conservation practices, save those scenarios, and actually share them using an open source platform called HydroShare, which we'll talk about in a moment. If you go to our website, modelmywatershed.org, all one word, you can see that we have the stream network for the entire United States. This is the very high level. If you zoom in, you can see the finest resolution blue lines that are currently available under the joint USGS EPA NHD plus version 2 dataset, if you know what that means. This is basically the reference stream network and boundary layer dataset that includes all the HUCs, for example. So all the HUCs from HUC 2 down to HUC 12 are encapsulated in our model, and the model operates over those regions, all the way down to the COM-ID catchment and stream reach level that is being used presently by NOAA for the National Water Model or USGS for the new National Hydrography Model. So pretty much all the models, Chesapeake Bay model, all run on this same stream network. It includes the National Land Cover Database that I said earlier at 30-meter resolution for the entire continental United States. It includes USDA's Surgo dataset for soils. It doesn't include the entire dataset because it's really has quite an extensive list of properties, but it includes the hydraulic response group, I think, HRG. I forget the exact acronym, that basically is about infiltration rate groups. And these are used by most models, including SWAT or HSPF and other models use this exact same data set. So the underlying data are the same as pretty much any model that you might think of. Finally, we have the National Land Elevation data set, which then routes the water even over the landscape. So we can do 30-meter pixel by pixel routing from one pixel to the other using this elevation data set. The elevation also includes slope information that we then translate into erosion using the universal soil loss equations. So that was just kind of the overview of the main data sets, and here's just a summary of them. We have some, precipitation, I guess, so that just kind of animated through the whole list. There's so those are the main ones that actually run the model that are required for all models. But in terms of parameterizing the model, you might recognize that, that's sometimes not enough. And so a lot of care has gone into calibrating the model and using as much location-specific information as possible to parameterize the model, right? So these are part of the enhanced version of GWLFE, even though it's a relatively simple model. It's calibrated to use these underlying data sets to further improve the outputs. So the first one is USGS base flow. This is basically from groundwater estimates of like how much groundwater is contributing to base flow during dry season conditions. So we're using a national data set for that. We have an estimate from USGS about groundwater nitrogen, which also helps us with our water quality estimates. We have a soil phosphorus estimate also from USGS for the country, which helps us with our erosion-driven phosphorus loading information, same for nitrogen. We are using the US EPA's reference weather station network that's been used for decades as kind of the reference data set for driving the model. So daily precipitation, temperature, etc., wind speed for calculating evaporation. So this is where I'm going to hand it over to Matt to kind of dive into a demonstration of what Model My Watershed can do and how one can essentially add different scenarios of conservation practices to a given model area and look at the results and compare the results between different scenarios. So I'm going to hand it over to you, Matt.
Okay, thanks, Anthony. So I wish I didn't need to say this, but a little bit of fair warning. I'm in a convention center on their Wi-Fi, and sometimes I apologize because you probably won't be able to see the full speed of the model because it's going back and forth to Model My Watershed and through the Zoom, which maybe I'll get down a little, but let me share my screen. So we're in Model My Watershed. This is not an area of the country we work in. This is in Iowa. We picked this, I'll just say semi-randomly to start to show you what we can do. I guess first thing on the login screen here, so it knows who I am, but the login is very simple. Name, email address, password, and then you can choose some attributes. Maybe the most important, maybe which unit scheme you want, if you want metric or US customary. And so we're going to dig into Model My Watershed, and the first thing to do to get started is to choose your watershed. And there's a couple of ways you can do this. The one I actually use most often, and I think sort of the most interesting, is to delineate a watershed. You'll see as we go through the model, there's a number of places where there's sort of a call out for Delaware specific information, and that's because a lot of money was invested in this model for the Delaware. So there's some high resolution streams layer, for example, a lot of it, some additional weather information that we'll get to later that's tailored to the Delaware because of that investment. So we'll stick with the functionality that's available nationwide. So when you click on that bar, you can see the screen, and basically I can go to any point along a tributary on the map, click it in place, and the model will draw the watershed and then clip out the relevant information. If this starts to take too long, we have some fallback options, but
Matt, can you enable the view of the continental US medium resolution stream network that's just under your mouse cursor there?
Yeah, I can. So I'm just going to get to the layers in a minute.
Yep.
Yeah, so why don't we do that now? So you'll see this box that has a number of layers. You can see there's several options to choose from. If you click on the continental stream network, it will expand the network. What you were seeing before was from USGS topo mapping. So actually, I'll go through the rest of that box now, I guess. So you can also click on different year land use land cover information. So I can click on the 2019 data. I could look at the 2011 data to look for changes. You can also click on a number of different boundaries, different HUC units, HUC 8, HUC 10, 12, county lines, congressional districts. You can see, I believe this is weather stations. So it turned those on, but it's actually outside of the boundary of the screen right now, so we're not seeing it. Let's see. And you can also call up satellite imagery with roads, which is fairly high resolution. And Anthony, can you tell me, as I zoom around in here, is this coming through okay?
Yeah, it's actually pretty
Great.
responsive, so it looks
Great.
great.
You can also look at a terrain map. I like the satellites. Sometimes it gets a little busy. So I
Click over on coverage. Sorry, on the coverage. So there's like these different sub tabs. So the second, the little grid one, just right there, yeah. And then yeah, the NLCD, and
right.
at the very top, for example, NLCD 2019. And I just wanted to show the translucent. So click actually,
I get you.
yeah. Now,
Yeah, so
a little slider that allows you to make it somewhat transparent. So if you get to like right in the middle level, you can kind of see the underlying either terrain or satellite map with the color coding of the National Land Cover classification. So it's kind of this like interesting hybrid view that you can get, which is very, very useful.
okay. So I want to go back, step back to the last step to look at just other ways you can draw your boundary. Let me get back to the paste card. So you can also select pre-existing boundaries, HUC 8, HUC 12s, HUC 10s. So if we say choose to look at a HUC 10, you can see that the red lines are delineating the HUC 10s. And if we select this, so we clipped out that HUC 10, and if you'll notice this is the sort of pseudo random part is we did choose one that encompasses the top of a watershed. It's not a HUC 10 that's downstream somewhere. So we're looking at that entire HUC 10 now, and it will clip. You can see here there's the stream network information. It will clip the land use, land cover, and we can go back and see this on the ground. So you can say we've got about 51% in cultivated croplands, about 30% in pasture hay, deciduous forest down around 7-8% probably. It will also give you your soil information for that entire HUC 10. And I should say, so you can also, there's a table below the graph that lists the coverage both in terms of area and percentage for all the land use categories. We'll give you terrain statistics. Under the climate tab, you can see, you can select from a number of options. You can see precipitation, you can see temperature in both graphic and chart form. So the model also includes point source data from the MPDES database. And in this case, the only information is for looks like a wastewater treatment plant with only nitrogen information, maybe. We've also, there's estimates of animal units. These numbers are from USDA's Ag Census. Those numbers are compiled at a county level. So the model sort of extrapolates those county level numbers to the ag acreage. And so there are often relics, you know, I'm guessing there's not 3 dairy cows, for example, in this HUC 10. There's probably 0 or, you know, 1 dairy farm. And when we get to the modeling piece, I'll show you how you can, if you have more detailed information, how you can address that. Probably also not 115 broilers. Would be an odd number. And then there are, right. So the water quality data is another tool that would have been Delaware specific. So if we want to make changes to this, you know, model out different land uses, different alterations in the watershed. There's a site storm model, which, as Anthony noted, was sort of a hybrid of SLAM and TR55 with EPA's STEP-L model that looks at single storm events. I tend to use the multi-year watershed model most frequently. So this is a piece that may take a little longer as it picks out all the data it needs. Okay, so as we look at this watershed, we can, over here on the hydrology tab that comes up initially, you can look at stream flow, you can look at surface runoff, again, both in graphic and tabular form, subsurface flow, precipitation. So plenty of options there. And you can also look at water quality information for the watershed. And so the nitrogen, phosphorus, and sediment loads are attributed to the different land uses. So you can see cropland up here jumps out, both because it's cropland and because it's was, I forget, 51% of the acreage perhaps. So okay. So let's say we wanted to think about what were some potential changes we could make in this model. So we can, over here on the right, under the add changes to this area, we can create a new scenario. Over here on the new scenario tab, you can, a little 3 dots to the right, you can click on that and you can rename it. So we'll just say trial 1. So we can identify it. And then we can do a number of different things. We can come over here in the land use land cover, and we can model the changing acreages from cropland forest or wetland. We're going to do wetland restoration work. So
Matt,
you can
I'm just going to interrupt you. It's Michelle.
Sure.
You've been a little bit choppy after you typed in trial 1. Should we try something else to improve the sound? Now you sound good.
of course. I'll tell you what, why don't I first try to.
You could make, I don't know if turning off the video helps consistently improve sound, but.
Yeah, why don't I try video to get rid of video first?
Okay.
Okay.
You sound good now. Thanks.
Give me a minute there. So for the moment, I won't alter the land cover, but know that you can do that. I think the use we see more typically is folks thinking about implementing certain conservation practices. So if we look at the conservation practice tab, and let's say we wanted to think about converting a significant part of this watershed to no-till, for example. So if I click on no-till agriculture, it will pull up, it will give me the number of acres in that row crop land use category. And I can choose a number to modify. So let's be ambitious and say, 3/4 of the watershed. And I can maybe say, so let's also look at, make the big assumption that we can get all those guys who are going to go to no-till to implement cover crops. We put 3/4 of the watershed into cover crops and no-till. And we can come back around the top left-hand portion of the screen. There's a button for compare. So you can click the comparison and you can look at the hydrology and water quality information in your new scenario compared to the current conditions. So you can see the reduction in surface runoff stands out pretty quickly with that large implementation of cover crops and no-till, for example. So you can look at all of the hydrology information, and then you can go to water quality and look at projected reductions in sediment load. So it has the bars, and when you hover over the bars, it'll give you the numbers. Nitrogen and phosphorus. And you can, you can play with these sorts of practice implementation to your heart's content. You'll see that the list is, well, I guess it depends on what you're used to and what your perspective is. I think it's a little limited. One of the things we're working on is fleshing this out and thinking about new ones. Another piece that can have, well, so let's create another scenario. We'll call this one I'll try 2. And now we'll put the cover crops in that we had before and no-till. And then add nutrient management to the mix. Shoot for the same percentages. All you guys who work on implementation work know that 75,000 acres of nutrient management planning is, let alone implementation, is nothing to sneeze at. Maybe we'll look at vegetated or stream bank fencing. So again, when you click on stream bank fencing, it comes up with the length of streams that you have in the ag areas. So it doesn't really know exactly how many of those miles might have livestock access. So you're depending on some of your own knowledge of the area to do that. But maybe we say 100 miles of stream bank fencing. And then we can come back here to compare tab and look at all 3 scenarios, current conditions in both trials. And you can see that it's, we didn't make that much of a difference at that Huck 10 watershed scale with the additional changes. Maybe we'll see a little easier to see some some impact on the loading scenarios for nitrogen, phosphorus, and sediment. So there are some really interesting opportunities to modify the model with better information, and I want to point them out. So if you look here over here on the right at the top of the screen at the weather data button, can't remember whether Anthony mentioned this before, but the multi-year model operates on 30 years of climate data from 1960 to 1990. So one of your first reactions to that may be, well, geez, our rainfall does not look today like it did from 1960 to 1990. So you have the opportunity to create a CSV file with custom rainfall data. There's a sample CSV file to download, so you know what you're looking to build. But if you have access to that rainfall data, you can upload it. And this is one place where if you're just playing with a model to see what it can do, if you click an area over in the Delaware River watershed on the East Coast, you can really look at the changes that happen. We have a more recent weather data set uploaded for the Delaware from 2000 to 2019, and then some future weather simulation data sets that look at future conditions anticipating climate change. I'll tell you, it's a little sobering to make those changes and look at particularly these ag landscapes in their current state with future weather expectations. But it's an interesting exercise to look at it. The other thing you really want to be aware of, I think, in terms of the tool is that if you click the settings tab, you have a lot of opportunity to modify the systems. So you can look at the reduction efficiencies, the model reduction efficiencies that are assigned to the different BMPs. If you have better data for your piece of the geography, you can modify those and compare those outcomes. We also have more detailed information about the wastewater treatment plants that are in the watershed that we've clipped out. One thing, working on a lot of farms, this is one place I go every time to true it up. You know, I tend to know a lot more about the actual livestock in the watersheds that we're working on, and can enter better information than just relying on the extrapolated county ag census data. So, you know, I could go in here and tell it, I know there's no dairy cows in there. And I either know there's no broilers in there, or there's a broiler list that might have thousands of broilers. So I can true that up. I think this is, given the impact manure has on a lot of our systems and the livestock densities we see in some place, this is one place where truing up details will help your model, will really improve your outputs. So there's some other data in here that you can also modify. Some of these things around stream bank erosion and sediment delivery ratios, it's hard to get good information on. I'll say that. One thing we don't deal with in the East very often at all is that a lot of tile drainage. So if you're in the Midwest and you've got a lot of drain tiles, and you know the fraction of farmland that you've drained with tiles, you may know some average nitrogen and phosphorus concentration from the discharge of those tiles. So there may be some ways in here that you can really improve the accuracy of your modeling effort. Okay, one more thing to show you before I hand it back to Anthony. There's So if you go back to the current conditions and you're under the water quality tab here, you can see this view sub-basin attenuated results. So when we clicked out this information for the HUC 10, Model My Watershed is calculating the results, the water quality results for each HUC 12 within the HUC 10. So if I'm looking at this overall HUC 10 and thinking, how do I better target my efforts? Where might I want to go to actually begin outreach to farmers for implementation or talking to folks about, practice cost share opportunities? I apologize, it's taking a minute. Maybe we should, Anthony, thoughts about how long we should leave it go?
Yeah, I guess I can pipe in and just say that the system uses it doesn't actually do, the computing is all happening remotely on a cloud server. So unfortunately, this is common when we're doing live demos using Zoom and bandwidth is being taken up by Zoom. It slows down the response times. So
let me
our apologies for this.
Let me stop my share and see if I can go to a preloaded example.
Yep. If you don't have that, I might. I know it's in the slide deck. Should I show my slide deck or?
Let me go back to share here.
All right.
Okay, so I had previously run this, so I'm calling up a model, an example that about the same watershed, but just have already done it, so it has the information. Okay, so once
if you click on one of those HUC 12s that's being shown there, it should highlight the colors.
Yeah, okay.
And then you can
so over here,
yeah.
once you double click on one of the 12, the HUC 12s that's part of that HUC 10, you can see over in the upper left, it comes up with 3 related layers and a little drop down arrow. So we can pick out nitrogen. And so this will look at the HUC 12 and you can move around and at the different HUC 12s and if you note these are the NHD watersheds, and you can see that each watershed is color coded and the stream segments are color coded. So the stream segments are color coded according to their annual mean concentration. Obviously the redder the stream, the higher the concentration. The HUCs are color coded according to their loading rate in terms of kilograms per hectare per year. So you may look at a HUC 12 like this and you can see where loads are coming from. And I know everybody has a different sort of appetite or for targeting, or different scale of targeting that they like to do. But you can think about these smaller watersheds, think about where to start, and then you can zoom in and choose one of these watersheds. I'm gonna jump to one more quick screen.
Seems to have lag there.
Yeah. So I can share again. So this, let me zoom out a little bit. So here's, you see my cursor, the larger Huck 10 is surrounding this little watershed that's cut out. So I could zoom in on this watershed, clip it out. Typically I use the delineate watershed tool and choose a point. And then we can look at within that smaller watershed, look at our soils, look at our land uses, and then we can go back in under the model tool and look at different scenarios. So in this scenario, I've implemented cover crops and no-till and nutrient management. And so then at this smaller scale, I can also come back in and look at what differences we might see in surface runoff, stream flow, as well as loads of sediment, nitrogen, and phosphorus. So that gives you a sort of a brief flavor of what the tool does, how it works. I know I went through a lot of things very quickly. I think if you jump in and start playing around with it, the interface is very intuitive. I came to Stroud after the tool had been initially built, but before it was really being utilized by folks other than students, I think. And having the GWLE model under the hood with such an incredibly easy to use interface has just been a tremendous asset for a lot of local watershed groups. I have a lot of colleagues who work at engineering firms who certainly don't use this for all of their workflow, but they use Model My Watershed to do a lot of quick and dirty work, sort of just looking at watersheds and assessing opportunities and thinking about work options in those places. So I'll stop sharing and pass it back to Anthony.
Thank you, Matt. I'll turn my video back on and start sharing. So there are a lot of help resources to kind of take it from that demo and explore. I mean, the best way to learn is to just explore it. We worked with this amazing team of user experience, user interface developers at a company called Xavia. They just merged and became a new company called Element 84. Those people are experts in this kind of thing. And so the design is meant to be easy to use. But if you're stuck on a thing or want more technical help, there is really quite a bit of resources available. And I'm screen sharing because I just kind of want to flip to I'm on the wrong one here. You know, you get to the Wiki Watershed website and you can launch the app. There's a help button if you're on the app itself. Here I am locally. There's a help button here, and that help button will kick you right to the help resources, and you can go and you can drill down in on the help resources, including technical documentation. The technical documentation really dives into the weeds. I'm gonna It's quite extensive. It has this huge, huge way to like kind of teach you about stuff, but then it has quite a bit of technical information about how the water quality modeling works. You can just see like the details that go into describing each one of these. I mean, this is almost like, this is a very extensive set of help functions. It even, if you jump down far enough, it even gets into the calibration of the system. And I mentioned that right now we're using kind of I would say a continental scale calibration, but it's pretty robust. These are the data points. You can see that there are some places that are missing, but we have a breadth of data points. These are calibrated watersheds with detailed data that have gone into, these are the data sets for each one of these watersheds that have gone into these global calibrations, right? So you can imagine that, you know, there's some errors here, but in terms of there is, you know, there's a big effort to make this universal. That might be the one drawback. If you were using this for some regulatory purpose, or you really wanted to get more fine-tuned, you would have to download the model files from the user interface and basically do a local calibration on your desktop. Going back to the PowerPoint presentation to just wrap this up, and I know I have an eye on time. I mentioned that, you know, all of this is open source. There's also information about these different components, like how the model works. One of those is a spreadsheet tool, and I'm going to go back to my web browser to show you very quickly the spreadsheet tool. Let's see here. I actually, where do I have the spreadsheet tool? It's over here. Sorry. I guess I won't get into too much detail about the spreadsheet tool, but the spreadsheet tool actually was funded by William Penn Foundation, and it's designed to be able to take data from Model My Watershed and do more customized project-specific work. And that's how the Pennsylvania Department of Environmental Protection recommends cities do permitting work, is to start with Model My Watershed, then move to the spreadsheet tool. There's another aspect, is that that the computer savvy people out there, we've developed what's called an application programming interface that allows us to run each of our functions that you can do, you know, that Matt just described. You can do each and every one of these from either an R script or a Python script. And that has enabled us to, and I'm going to go back to the PowerPoint quickly, to do some pretty detailed pollution assessment, right? So in the web user interface, Matt was showing this hotspot mapping work for just a single Huck 12 at a time. Here's one where we automated that work for the entire Delaware River Basin, and with really fine resolution maps. And here's just a quick presentation. We're doing this for the William Penn Foundation to evaluate how much their last 8 years of conservation work, their last $100 million has paid off. And in the watersheds that they focused on, it really made a big difference, including downstream differences. In the interest of time, I'm going to kind of move quickly. There are a lot of people using this tool. It's being published about in articles on how to use it. There are several articles that have been published about it, both, you know, in the peer-reviewed literature and elsewhere. We've received numerous awards, as I mentioned, and a lot of our existing funders are really happy about what's happened. That said, we definitely have a growing consortium of interest and potential funders that we're pursuing right now. Some of our hot leads have gone, unfortunately, cold, but we see a lot of opportunities to make this even better. Matt mentioned climate drivers, you know, future more recent climate. potentially additional models, et cetera. There's really quite a few opportunities. Maybe the most interesting one is that we've recently connected this in a programmatic way to a project management system called Field Doc that you might be aware of. This is just a mock-up of what we could do where we could potentially integrate that in the user interface so that you could actually have project-specific information showing up on the web user interface. Could be used for all sorts of things. Potentially could be used for water risk analysis. These are all ideas that we're floating around. So lots of opportunities. With that, I'll just say thank you all, and we look forward to your questions.
Thanks, Anthony. We do have some questions. I know it seems like Matt's kind of answering some questions, typing them out, but there was a few questions on what is the largest scale this tool can be used. At large scale, does the model have buffering issues? And does going large scale have an impact on accuracy results from already generalized data inputs?
Yeah, excellent question. So right now we limit the web browser to model about a Huck 8 or so, because larger than that scale, it's not exactly Huck 8. I think it's 8,000 square kilometers. And as Matt mentioned, you know, in a user setting, you can change it to US customary units or metric units. So sorry, I'm stuck in metric. So 8,000 square kilometers is the maximum size that you can model in the web interface. But using that API and a little bit of Python scripting, following some examples, you can actually scale it up to multiple Huck 8s at a time and model something like the entire Delaware River Basin all at once. It just requires a little more patience and some scripting skills.
Thanks, Anthony. Another question, where does the information about water quality come from?
Sure. So it comes from estimates from GWLFE modeling the landscape, right? So using all those input data sets. GWLFE is very similar to SWOT, which I think is widely used in the Midwest for engineering purposes. GWLFE really uses very similar algorithms to SWOT, very similar inputs. It's slightly easier to use and runs a little bit faster, has a little bit less customization, but it's very similar. So essentially it takes all that input from the soils data, the land cover data, and then models the water flows, figures out how much is going over land and surface runoff that could cause erosion, how much of it is being infiltrated and comes out later as base flow. It balances soil moisture, all that business. And based on land cover and some of the soil data sets that go into the input, it models what the loads are based on empirical, basically regressions, just like SWOT does, of how different combinations of land use, soils, produce different loads in watersheds when there's a certain amount of runoff happening. And then it adds it all, and it does this on a daily basis for a 30-year period by default, and adds it all up to become average annual loads. Loads being, you know, total pounds or kilograms of the pollutant over a year.
I would add that it also integrates the manure from those animal numbers that are under that setting tab, and that you know, in any area, you know, if you've got a high livestock density, that can really make a difference. So that's why truing up those numbers is one of the key pieces of our use process.
Yeah, I'm glad you brought that up. And it also has as inputs point sources from like sewage treatment plants. So those are all in here from the EPA databases on point sources. So those are all in the mix also. And you can kind of tell, like in some of those panels that talk about the different sources, you can see what percentage of your nitrogen load is coming from sewage treatment plants versus ag lands. Like those are all listed there by source, right? The model can tell you also like what percentage is coming from animals versus cropland versus forest. versus point sources.
Thank you. I see somebody voted this one up. How is stream bank erosion estimated?
So I'm glad this one came up, and I wish we had a little better answer. So the stream bank erosion numbers are backed into a little bit. I mean, so Russell's generating the overland soil loss numbers. So this is a place that's a little messy. We know, particularly using old rainfall data, that those estimates for overland flow are probably low, and since the model's calibrated, it pushes extra reductions or extra load into the stream bank erosion category. I think the other thing that's sort of important to remember to know about the way the model thinks about it, and Anthony, you can disagree if you think I'm not on point, but I think of that stream bank erosion model even being in error as being more about mobilized load, not downstream, not exported load. So a lot of that sediment that's mobilized may end up on the floodplain. It may end up on point bars. It's not really indicating export from the watershed.
I would just say, yeah, the GWLFE model is sometimes criticized for attributing too much of the sediment to stream bank erosion, and there's a lot of nuance there. The truth is that it's been calibrated so that the total export loads are not off base. It might appear like they're there, but as Matt just pointed out, there's actually, like, when you move from runoff during a big storm down, from a field to actually the stream, there's lots of like intermediate storage zones, and think of stream bank erosion as kind of like mobilization of each of those. So it's a little nuanced. It gets the right answer in the end. It might sound a little high, and there's some debate about what that means. When a stream floods, there's a lot of sediment in it. Like, it goes up by a factor of 1,000, right? 1,000 times more sediment. And a lot of that is just being mobilized from one stream bank and deposited on another stream bank downstream. And so this is like trying to get that answer roughly right. It's been a little problem, because if you're not thinking about it that way, it might lead you to say, oh, we need to do a lot of stream bank stabilization, and that may not be the best alternative you've got. That's exactly right. The ultimate source of the fields, not the stream banks.
Yeah.
Great, thanks. There's a couple more questions on BMPs here, so I'm going to kind of try to combine them in the interest of time. But Amy asked, are BMP efficiencies pulled from step L or from something else? And how are BMP reduction efficiencies determined, and how regionally specific are these?
Right.
So
good, excellent question. The BMP efficiencies are not coming from step L. They've evolved over time, and I guess the short answer is that they are presently very, very informed by the excellent work done by the Chesapeake Bay modeling team and CAST. So a lot of that BMP efficiency work comes straight from that, including the whole performance standard approach for urban stuff. And it's actually a pretty sophisticated BMP method. So that's kind of under the hood. What's exposed in the web interface is sometimes simplistic, I will say, and enhancing what is exposed to the web user interface would be something that would be a welcome benefit, right? Because right now, you can't choose between different types of certain things, but under the hood, we have like more than 100 different BMP subtypes that we're modeling, and that spreadsheet tool allows you to access those.
great, thank you. I'm trying to look through here and see a lot of good questions that came in on this one. So somebody asked, where does the information about water quality come from? I think you kind of covered that, but if you have anything to add.
I don't think so. I didn't answer the regionalization thing, right?
Oh,
so
yes, yep.
Chesapeake Bay model is a very big region, right? It's half of the eastern seaboard, really, all the way down into into Virginia, North Carolina, as far north as the Catskills of New York. So I think they're reasonably good, and there has been a decent amount of attention paid to more ag land examples. You can see that there's a bunch of calibrations that were done for the state of Texas and kind of the southern Midwest. It's sure that things could be improved. There are lots of opportunities for that, but like I said, we put decent care into making them work.
As we wrap up, I did have a question. Anthony or Matt, you were mentioning the Pennsylvania Department of Environmental Protection, if I got their DEP acronym right, was encouraging folks to use Model My Watershed rather than another tool. And so who were those folks they were encouraging to do what with MMW?
So Model My Watershed's being used by both agencies and NGOs who are working on developing TMDLs for impaired waters. Excuse me. And that's, yeah, I mean,
And
across
yeah.
Pennsylvania.
And to add to that, TMDLs are total maximum daily load allocations for non-point source polluters, right? It's so it's a method of trying to say, we have an impaired watershed, and this is how we're going to allocate responsibility to clean up. I guess it includes point sources, but it's designed to include non-point source pollution, including ag lands. And so it's part of that mix.
I did want to add, I realized we glossed over a couple important pieces. All those outcomes for land use, for water quality numbers can be downloaded as Excel files. So you can really tease through some of the details of that in the numbers if you want. And it's not too hard to find. There's a download data button. The other thing we should have mentioned is that you can, when you're working in one of these models, you can share the information in two ways. One is it will generate, I think the button is actually share. It will generate a link. So you can email a colleague or a friend, a link to the exact file that you've set up, share, right? And you can also export it to HydroShare. So if you're just sharing a link, it's obviously going to only to whoever you're sending it to. If you export it to HydroShare, you can share it broadly with people. You can make it private and only allow certain people access to it. But and it's a really convenient way to share the information and the work you're doing with your colleagues. And Anthony, you may want to say more about HydroShare.
Yeah, I'm kind of doing a screen share right now, which you might not have noticed, Matt, as you were talking. That kind of showed where the share button is. And HydroShare is this community-sponsored system for basically sharing any information about watersheds. And so we're just leveraging it to be able to share modeling results. And the beauty is that it all happens automatically. So you create this link, and over here you can open it with Model My Watershed, right? I mean, you can either view it or open it, or it also creates this, like, it basically auto downloads all those tables that Matt was just talking about. And, you can just download this entire package of all the outputs from a single modeling run, right? I mean, look at them all, right? These are all these different scenarios that were run, all the different analyses that were run behind the hood, even like GIS information for the area of interest. All that information gets exported, and it actually exports with a spreadsheet tool pre-populated. So it's a pretty fabulous way of taking your analysis to the next step. It even exports with, if I'm not mistaken, although I'm not seeing it here. Oh yeah, this GMS file is the input file to run the model on the desktop MapShed software. So you could do a local calibration.
Thanks, Anthony. Would you mind putting your, there's a couple people I think have some more questions, but they can email those directly to you probably. Would you mind putting up your contact information that you had on that last screen for them? So yeah. All right. Well, thank you, Anthony. Thank you, Matt. And thank you for everyone that joined in. If you have any questions about the tool specifically, you can reach out to Anthony and Matt. If you have any questions about the webinar series, feel free to reach out to us, and we'll be following this up. There's a question about the slides. We will send out a recording and slides in just a few days. So be looking out in your inbox for that. And we will see you next month on July 12th with the nutrient tracking tool. So thank you, everyone.
Don't forget to fill out the survey evaluation form. Should take 2 minutes. Help us improve on the next webinar and the whole series. Thank you. Thank you, Anthony. Thank you, Matt.
Thank you
Thanks
all.
for having us.
Yeah, really appreciate it.